So now let's get into the lesson. First, let's learn about changes caused by heating. When an object is heated, it gets affected in one or many possible ways. And next, let's see about some objects get hot but do not change in any other way. Some objects get hot and also expand in size. Some objects get hot and begin to burn. Some objects get hot and change their state. Now let's see about changes by applying pressure. When we apply pressure to an object, we can change its shape and size. Air can be compressed. Metals can be harmed into their sheets. Elastic can be stretched. Cotton can be spun into their threads. Next, let's see about we can bring about a change in a substance by doing one or more process of following process like heating, applying force, mixing it with something else, and now let's see about changes by mixing a substance with other. We can bring about a change in a substance by mixing it with other. For example, making solution by mixing water-soluble substance in water. Metals expand on heating and contract on cooling. Chemical changes. What are chemical changes? These are the changes in which chemical properties of a substance change and a new substance is formed. For example, cooking of food. Physical changes. These are the changes in which physical property of substance change and no new substance is formed. Characteristics of the physical changes. No new substance are formed. Products are identical to the reactants. These changes are reversible. Characteristics of chemical changes. Properties of products are different from the properties of reactants. Most of the chemical changes are irreversible. We can bring about a change in a substance by doing one or more process of following process like heating, applying force, mixing it with something else, and now let's see about changes by mixing a substance with other. We can bring about a change in a substance by mixing it with other. For example, making solution by mixing water-soluble substance in water. Metals expand on heating and contract on cooling. Chemical changes. What are chemical changes? These are the changes in which chemical properties of a substance change and a new substance is formed. For example, cooking of food. Physical changes. These are the changes in which physical property of substance change and no new substance is formed. Characteristics of the physical changes. No new substance are formed. Products are identical to the reactants. These changes are reversible. Characteristics of chemical changes. Properties of products are different from the properties of reactants. Most of the chemical changes are irreversible. These changes always result in energy changes. Friends, kindly please note the points which are shaking. And friends, now let's see about reversible changes. These are the changes that can't be reversed. For example, stretching of rubber. And next, let's see about irreversible changes. These are the changes which cannot be brought back to its original state. For example, burning of paper. Now, Let's see about melting point. A constant temperature at which a solid starts melting. This temperature is called the melting point. And now let's see about freezing. A process in which liquid changes into solid form is called freezing. Now let's take an example for melting. For example, now let's take an ice cube, and if we heat it, it melts and it becomes as a liquid. As we see in the freezing process, if we freeze the liquid by keeping in a freezer, it changes into a solid, which is called an process called freezing. And now let's see about force. A push or a pull acting on a body which tends to change its shape or rest in motion is called a force. Natural changes. The changes which occur in nature on their own are called natural changes. For example, change of day and night, changes of season. Slow changes. The changes which take longer time to occur are called slow changes. For example, rusting of iron and tooth decay. Now, let's see about changes. Many changes are taking place around us on their own. Example, flowers bloom and then wither away. We can also bring a change. Example, change in the size of a balloon by blowing air in it. Contraction. A process in which an object becomes smaller or shrink is called contraction. Now let's see about evaporation. A process in which liquid changes into vapor is called evaporation. Next, let's see about expansion. Yes, expansion. A process in which an object becomes bigger in size. Example, metal expands on heating. Next, let's see about melting. A process in which solid melts to become as a liquid on heating are called melting. Now, let's see about reversible and irreversible changes. Changes that occur around us can be broadly categorized as reversible or irreversible depending on whether or not they can be reversed. Now, let's see about reversible changes. The changes that can be reversed are called reversible changes. What happens to an ice cream if you do not finish it quickly? It melts. Can you change the molten ice cream back into a solid? Yes, just keep it in a freezer. The molten ice cream can be changed back into its solid form. Thus, melting is a reversible change. Melting of butter and chocolate are also reversible changes. Now let's see about what about condensation, freezing and evaporation of materials. If you take out some ice cubes from the freezer and keep them outside, the ice cubes will absorb heat from the surroundings and melt, which this water molten ice is heated for some time. It starts boiling, liquid starts to evaporate, and steam escapes from the container. Now, if you hold a lid over the container, the steam will again liquefy or condense into small droplets of water on coming in contact with the cold lid. This water can be cooled down further and then kept into the freezer to form ice again. Thus, the three physical states of water are reversible and can be changed from one state to another by heating or cooling. And these are some examples for reversible and irreversible changes. Now let's learn about irreversible changes. Changes that cannot be reversed are called irreversible changes. These result in a new material being produced. They may or may not be useful. Some examples of reversible changes are given below. The ripening of fruits is an irreversible change because it is not possible to get back the fruit from ripened or mature one. Blooming of flowers is an irreversible change because flowers cannot be changed back into buds. And milk gets spoiled when not refrigerated. Particularly in summer, this is called curdling or souring of milk, which is an irreversible change. Curdling off is also done by adding lemon juice to milk for making cottage cheese or paneer. This is also an example for reversible change, which is called burning of paper. It's a reversible change. A new substance called ash is left or formed after a paper has been burnt. This new substance differs from the paper in appearance and properties. Now, let's see about cooking of food is an irreversible change because we cannot get back the ingredients in the original after cooking them. For example, after a cake is baked using flour, egg, milk and chocolate, etc., which cannot be get back the ingredients. Burning of a candle is often cited as an example of physical change because what we see is immediately melting of wax that solidifies on cooling. However, when a candle is burnt, the wax is undergoing two changes at the same time. First, it melts and then it burns. What burns is actually melted wax. The melted wax burns on the wick. The wick itself is not burning. It is just wax on it. Physical and chemical changes. Changes in which no new substance are formed are called physical changes. For example, breaking of a glass, freezing of water and tearing of paper and etc. Changes in which new substances with different properties are formed are called chemical changes. Cooking of food or burning of substances are chemical changes as entirely new substances are formed. Burning of a candle, wax releases carbon dioxide and water vapor. And now let's see about an example of physical change and chemical change. Now let's see about an expansion and contraction of materials. Some materials expand on heating and some contracts on cooling. Heating makes the loose particles that from the material expand or become loose. Cooling makes the particles that form the material contract or become too tight. The amount of expansion differs in solids, liquids, and physical change. And gases. Gases expand the most while solids expand the least. These are the examples for expansion in solids, expansion in liquids, and expansion in gases. So let's learn about these examples. For example, now let's see about expansion in solids. Railway tracks consist of two parallel metal rails joined together. Small gaps called expansion gaps are deliberately left between the rail as there is an expansion of the rail in hot weather. Expansion in liquids. Water expands on heating. Try this with the help of an adult. Take a glass filled with the water to its brim. Pour the water into a container and heat it. Do not boil. Now try to pour the water back into the same glass. The water overflows. This is an example for expansion in liquid. And now let's see an example for expansion in gases. Take a balloon. If you keep an inflated balloon in the sun for some time, what will happen? It will grow in size as the air inside it expands on taking heat from the surroundings. These are the three examples for expansion in solids and for expansion in liquids and also expansion in gases. And now let's see about application of expansion and contraction. Expansion by heating can be used in several everyday activities. The jammed metal lid of a jam jar can be opened by heating. The jar is inverted and just the lid is dipped in hot water. After some time, the lid can be opened easily as the lid gets slightly expanded. The fact that materials expand on heating is used in thermometers. In many thermometers, mercury is used. When the bulb of the thermometer comes in contact with a hot object, the mercury expands and its level rises in the glass tube, indicating the temperature. And the next point is why the electricity lines are never hung tautly between the poles. Wires in the outside environment are subjected to extreme weather conditions ranging from acute hot to cold temperatures. A taut wire on a contraction in winters can snap. Now, let's see about reversible change. A change that cannot be reversed are called reversible changes. Friends, that's all for today. Let's see in the next video. Till then, bye, and don't forget to like, share, comment and subscribe. Bye friends.